So, couple of things before we get started. Was anybody weirded out by the fried chicken? The name of that? So, who's not from Austin and kind of wants the rundown? Yeah, a couple of you. So, we're from Texas, and you know, we're not always the deepest thinkers. So, somebody said, hey, we ought to fry that chicken, it'd be better fried. And then somebody else said, hey, we need to put steak in that chicken fried wrapper, so we're going to make chicken fried steak. And then time passes, and then somebody said, hey, we should put chicken in there. So then you have fried chicken. So that's basically what happened. Don't look at your program, and if you do look at your program, you'll notice that I've changed the title of this presentation, and I also changed a couple of I changed it all. It's a different presentation. After talking to some of you and talking to Jim and the team, we decided that one of the things that was really needed was a language adoption talk, where you could basically go home and talk about some of the reasons that I believe that things are changing fundamentally on the language adoption side. And the platform that I'd like to use to talk about this topic is the idea of fear and its role in language evolution. For those of you who don't know me, my name is Bruce Tate. I'm from Austin. If you've been near Lake Travis earlier this year, I went on a kayaking expedition where we went down all 64 miles, well, at least the 42 miles that still have water in them. And I had a lot of time to talk or to think about fear. It was going to be a 2-day trip, and about halfway through the first day, it was apparent that we would have to choose our camping site at night. And if you're from the north or someplace that doesn't have poisonous snakes and scorpions, you might think this is not a huge deal. For me, it was a very big deal because I don't like either one of those things, and my light setup wasn't that great, so I was kind of writing the talk in my head during this trip. Then I thought, fear is an amazing thing because it has the power to shape places, to shape geographies. You can even see the results of fear from space. There's the Wall of China right there. And if you think about the role of fear in the world, in the shape of the world, in the way that we draw the lines between our nations, fear has an amazing role. In fact, you have to overcome a huge amount of fear to do any kind of real discovery. So I thought I would talk about fear in language creation. And then Jose did his part of the talk, and he talked about his pit of despair and talked about exactly this. So I thought, fear plays a big role almost always in the creation process, but you can even find books on writer's block and basically writer's block for artists as well. But since Jose has already talked about this, I don't want to do that. I basically want to talk about fear and the role of language adopters. Let's face it, everybody in this room, we're language adopters right now, and we need to be thinking about whether this marvelous thing that Jose has built is going to work for us, and whether it's going to ever achieve the critical mass to get off the ground. And so this talk is about the role of fear in that, the opposing fear that's going to keep that from happening, and the motivating fear that's going to kick us in the butt and actually move us to the point where we'll reach a critical mass. And there was a book that was written in just after 1990, 1991, by a guy named Jeffrey Moore. How many of you have seen Crossing the Chasm before? So this is often a popular talk at language workshops, so I'm not going to rehash all of this. But I do want to put this in context of technology adoption and really language adoption. But Jeffrey Moore argued that there are 5 groups of people, that there are early adopters, there are innovators, early adopters, the early and late majority, and then the laggards. And squarely between the early adopters and the early majority, there is a chasm. But in fact, you see this kind of adoption curve, and many times in our industry, you see it every time a new language is adopted. And in fact, these waves, these adoption waves, are very irregular when you talk about them between languages. You can probably think about some languages that were adopted very quickly, and some that were gone just as quickly, and others that took a while to adapt or lasted longer than you might think. And the things that are important when you're adopting a language, when it's a small step, are things like syntax and types and libraries. This is why you often see comments about Elixir's syntax first. That you see, this is kind of like CoffeeScript for JavaScript. It's not really the same thing. But this is why you get that kind of perception, that kind of misconception, a misread of what the Elixir language is all about. In reality, what we are doing is not just changing a programming language. We are changing programming paradigms. We're going from object-oriented languages to functional programming, and we're also making a move from a single process language or even a multi-threaded language which that puts all of the burden of concurrency management on a single developer to a multi-process system. And the way that you think about it, the mental model, is dramatically different. So in this case, the waves are much bigger, there's much more space between them, it's harder to push those waves through. But when they come, the inertia is that much greater. And so I want to talk about that during the course of this talk. And the idea that the mental model is really the thing that we are overcoming right now. It's not just syntax. It's not just a set of libraries. It's not even going from static to dynamic typing, as many of the Ruby people in this room were used to from the last move. So let's go back to Geoffrey Moore. Let's think about the chasm. The chasm is between the people that have the ecosystem on the right-hand side and the sad people on the left-hand side. Right? And the things on the right-hand side are the things that the people on the left-hand side want. They want the tools, the community, all these things that make us more productive. You know, we're here at a conference. You can get training for Java today. You can find Ruby frameworks like Ruby on Rails. You can get jobs in these spaces. But the most important thing is the beer, right? So if you think, hey, we have enough community, we have everything we need, you know, I think we want to be on the other side with the beer, right? But this is about as far as I'm going to take Geoffrey Moore. So everything from here forward is Bruce Tate, not proven. This is hypothesis. This is based on observation. So it stands to reason to me that fear can work in both directions, right? There's initially, you think about the paralyzing fear that's going to make the chasm wider. Right? If you think about it, this is the main thing that you have to overcome when you're writing a new language, when you're trying to get that language adopted. Right? These are the things like, can I afford it? Is this thing going to be abandoned? Do I have to retool? Can I afford it? What will it cost me? Right? Is this going to break? Is it going to be too difficult for people to learn? These are the typical fear-based issues that are going to turn a small chasm into a very big one, especially when I'm moving between not just languages, but programming paradigms. This is the mental model that Francesco was talking about earlier today, and the hard part in moving from a traditional language. This is the new language graveyard. This is where languages go to die. So what we have here, what winds up happening is, based on the paralyzing fear, even if there are new languages that are being developed and pushed and hyped, there can be some very big languages parked on the right-hand side for a very long time. Right? But when you're talking about new paradigms, these cycles get even longer. The problems become much more pronounced, and the paralyzing fear gets to be almost too much to manage, because not only do we have to retool our own company, but the industry has to retool. Right now, the way that we think about concurrency, the way that most of us were taught in college, is that you manage concurrency with threads and locks, and that's not going to cut it for the next generation. Right? So you have longer cycles. That means bigger chasms, and the motivating fear is in the middle of all of that. So what I'd like to talk about is the last time that we crossed the chasm, we had a language on the left-hand side. It was Java. We had a language on the right-hand side. It was C++. Now, it might look on this chart like we weren't changing paradigms at the time. But how many of you were around for this transition? Okay, how many of you were using C++ at the time? Okay, how many of those people were using C++ in an object-oriented way? One or two. I don't believe you, but maybe you were. So maybe I found the two people on the plane. Okay, we're getting a little bit more honest here. So it's always been my contention that C++ had all the object-oriented features. You didn't have to use them, so it was more of a C++ minus minus, right? This was a procedural language, right? And what we had was really Java and a lot of other players that were trying to break across this chasm. And this chasm was there because the industry, the programming industry, was facing a lot of challenges at the time. Like, how do I distribute my applications? Not just across 2 tiers, but 3 tiers, right? IBM had this sales pitch called the N-tier architecture, right? And we were all talking about this thing. We were talking about how to do windowing systems. So now screen sizes weren't 80 by 60 or whatever. They became 300 by 600. So the resolutions meant that we had to basically manipulate more bytes on the screen. We had to send data across the wire. Performance was a big deal, right? So some of the paralyzing fears were that there was going to be too much to learn for object-oriented technology. There's also the idea that when you bought a C++ system, you were also buying a vendor and you were joined at the hip for life, right? And when you were on a single vendor system, basically at that time, unless you were talking about the client, you were probably joined at the hip for life to your hardware vendor too. This was a much bigger commitment than back then to C++. So over time, the paralyzing fear was mitigated a little bit. You didn't have to learn quite as much because some of this was a syntax deal, right? Some of the reason that we're here is that we have a Ruby-friendly syntax, right? That doesn't get you across the chasm, but it does get you into the door. It helps to mitigate the problem somewhat. There was the internet that opened up some of the systems, so rather than dealing with proprietary hardware and proprietary software, I could deal much more with open systems. And then there was the JVM that made Java portable across the systems. And the motivating fear was deployment. Here's what I mean. How many of you remember installing early versions of Windows? When was Java? 1996? So Windows 95. How many of you ever had to install that? Do you remember how many diskettes? And we are talking diskettes. 6? More than 6. There were 10. Right? There's the stack right there. Right? And that was the deployment story, right? There were other people that commercially had solved the deployment problem. We're talking about 1996, and we heard Erlang solution to deployment that was around in 86. Right? But here we're talking about a different culture, the culture of how do we develop software on the client. And these people hadn't really worked it out yet. This was Microsoft and IBM and a few other players. But this was a story. You would take those diskettes, you would get your roller skates on, and you would go from one system to the other and feed the machine. And the system got a little bit tougher when you talked about how many clients that you were installing. And then maybe you had more than one location, and this kind of started blowing up, right? So you can imagine what the deployment story was. And we're not just talking about Windows at the time. What else did you have to keep up to date? Yeah, Office, right? What else? Internet, well, no, we're not talking about deploying in a browser, right? The browser's not in play yet. The database engine, the LAN management, communications management, because we were doing things like screen scraping to integrate with that N tier, right? That beautiful N tier on a chart meant that I basically scraped the screen, right? And moved data around that way. So this situation really became unmanageable around 95. And that's before we even had to talk about things like multiple vendors and the fragile techniques that we were using to program, right? So and the C++ memory model that didn't have protection between one segment and another. And this basically crushed us under our own weight, right? So this is the motivating fear. This is when I say that that fear has two impacts on language adoption. Normally, the paralyzing fear stops everything in its tracks until there's a big enough motivating fear that kicks you in your pants and basically punch you across the chasm. That's a business goal. So my favorite display, my favorite slide all day long was Robert's when he said, we weren't trying to build functional software. We weren't trying to to use actors. We were trying to solve a business problem, because this is how languages get adopted. Right? And then the internet happened. And when the internet happened and Java married itself to the internet, the deployment problem suddenly went away. You didn't have to deploy to clients anymore. You had to keep one thing up to date, and that was Internet Explorer. You could move the rest at your own pace, right? And Java across the chasm. So here we are, and Java's across the chasm. And teed up on the other side of the chasm are all these beautiful languages that we'd love to use. Well, all these languages, some of which are beautiful that we would love to use. And so we are waiting for the time when the paralyzing fear is smaller and the motivating fear is bigger, so we tip and we cross the chasm. So the question that we need to be asking ourselves today is, what are the paralyzing fears and how are they getting smaller? And what are the motivating fears, and are they strong enough to punt us across the chasm? And you already know a lot of the punchlines before I even go through the rest of the talk. You're already going through the arguments in your head. You know that multi-core is coming. You know about the power of this community and that it's growing, and that you'll be able to find or train Elixir programmers from the people in this room, because you've seen it happen a couple of times. But you need to be able to, this is the story that you need to be able to articulate to your management to do this for a living, right? If not now, then soon. So the first question is, how are the paralyzing fears getting smaller? And I think that there's a question that we have to ask. What's the best way to eat an elephant? One bite at a time, right? So let's look at the little ways that the paralyzing fear is getting smaller. And maybe they'll add up to an elephant-sized, thing on the weight, thing on the other side of the scale, right? So I think the number one way that the paralyzing fear is getting smaller is kind of at this table, right? So Jose, where were you born?
Brazil.
And where are you from now?
Poland.
And where are you from?
Sweden.
And when did you meet?
Today? Yesterday.
This is the core team. Building communities is different than it used to be, right? Dave is born in London. Born in London, is that right?
Up at Liverpool.
Okay, up at Liverpool, okay. Born in England, and now in Dallas. And this is the core of what's happening in Elixir, right? And if you ask around in this community, how many of these people have met for the first time this weekend? Most of you, right? How many of you are from Austin? How many of you from somewhere else? How many of you from across the pond, a different country? So that's kind of amazing in itself, right? So we're up to, not quite 10% of the group, but a bunch, right? And this is just the people that are willing to get on an airplane to learn about Elixir, right? The internet is making the world much smaller. Conferences like this one are making the world much smaller, right? Building communities is much easier. The second thing that's happening is you are starting to see more functional ideas in object-oriented languages. Even Java has closures. Java has closures. I mean, that's crazy, right? So when I was in Norway a couple of weeks ago, I met my good friend Venkat Subramaniam, and he was teaching a class called Functional Programming in Java, right? Every time that you add a bridging feature like that to an object-oriented language, the chasm gets easier to cross, right? We're exposing a new set of developers to these functional techniques, and these functional techniques work, and they drive costs down. And every time that happens, the value proposition for functional programs gets better. Deployment options are also much more widely available than they were. We don't have to retool the whole hardware stack at our companies anymore. We've got the cloud. We've got the Amazon services. There are options for deployment that might take some tweaking from what we were doing with Erlang, but they're either available now or will be pretty quickly. And the last one is, I think that interfaces between programs are getting cleaner. So since the last paradigm shift, we have an internet standard which makes applications a lot easier to write, which makes it easier to carve my application in pieces, right? So I'm speaking with Eric and Jose about the potential of running Elixir in my company, and I know that with our small development team, I can't do it all at once, but I don't really have to. What I'd like to do is skin the application in Rails, do the back end in Elixir, and get the benefits, right? That's where all my latency is, between the database calls. I don't have to do it all because my interfaces are cleaner now. A REST-based API is easy for me to write, easy for me to build, and it's easy for me to consume. So let's talk about the other side of the chasm, the motivating fear, right? So always the first motivating fear is code complexity, right? And a lot of the complexity this time comes from this big freight train that's coming down the tracks that's called multi-core. It's why a lot of us are here. We know that there's no free lunch anymore, and we know that, that we have to solve the code complexity problem of concurrency. Can Ruby do concurrency? Yeah. Can it do it well? No. Why? Because the burden is on the developer. We need that burden to be completely solved by the programming language. So here's an example from my book, 7 More Languages. So this is a state machine done in Elixir. And so basically, this allows a usage model that looks like this. And I could throw my video straight through a pipe, that takes me through the states of a state machine, and then have that manage all of my business callbacks. And when it's time to distribute that state machine, I have all kinds of options that are going to let me do that in a transparent way. This is an OTP application that uses a DSL. How many of you have written an OTP application in Erlang? How many of you used Emacs? Almost all. So why did you guys use Emacs? Yeah, okay. Why would you have discovered Emacs if you didn't use Emacs for everything to do OTP? Come on, we all know, you can say it. There's a magic OTP key, right? That throws out, I don't know what the Erlang boilerplate is for the magic OTP, but it's pretty big, right? And what Elixir allows us to do is to take advantage of all this great wisdom from the Erlang community and apply a new technique that's generated in the Closure language, apply it to a rich syntax, and basically allow us to distill the application. So this in Elixir replaces something much larger, which replaces an Erlang. It's too big to show. The code behind the Emacs key, right? Thanks to Dave for the first cut at that DSL, and to Peter Minton for the example. Okay, now complexity. Let's talk about complexity one more time. So crossing the chasm this time isn't just about Elixir. This is about the family of languages, about the paradigm shift, and the idea that we have a new family of languages. A lot of the thinking in language design right now is happening on the client side, right? And so one of the things that I've tried to do with the 7-language series is I try to solve a non-trivial problem by the time that the book's over. Now, the first program that I ever wrote that had any consequence was a game that I wrote in BASIC, and I love BASIC. But the nice thing about writing games way back then was that the machines were slow enough that I didn't have to worry at all about timing and synchronization or anything like that. I just said, okay, if you got a faster machine, you just had to play the game better, right? It's just going to run faster. Since then, I haven't written any games because I hate dealing with the timing issues. And the changing values over time and managing that, it just got to be too much. Well, in Elm, with 120-something lines, 130 lines of code, I don't know what the exact count is, but there's a application. Let's see if I can show you guys. So we're going to, getting dangerous here. Okay, that's what I'm doing right now. Come on. You know you want to mirror. What's that? Okay, F1. Here we go. So here's the game. Yeah, this is kind of funny. So see how many of these people that you recognize. And this was written in 130-something lines of code. This is called language heads. That's Dave as a garden gnome, right? That's me as the Incredible Hulk. But all this stuff is happening in 130 lines of code. That's the rotation, the scoring, and everything. There's Joe Armstrong. That's language heads. Okay, and that, so basically the paddle movement looks like this. So I'll draw a paddle, and I take the dimensions of the window and the X location, draw a black rectangle, move it on the X dimension, and move it on the Y dimension, and I'm done, right? And to display it, I basically draw a collage with the paddle, and main basically says take this signal and lift onto it these particular functions, right? So the input stream gets managed by the last line of code. So there's no callbacks here. This is just functional compositions. And the more complex your applications get, the more that this makes sense. So the timing part of the game is all managed in about 8 lines of code. Everything else is done by the reactive framework of the application. Okay. So basically, my perception is that there's an elephant sitting on one side of the chasm. As the paralyzing fear starts to shrink, and it's shrinking, we can see that happening. As the motivating fear gets stronger, and we can see that happening, especially with code complexity and multi-core, we have to do something, right? So now I think the question isn't whether Java is going to be sitting on that side of the chasm, it's which language it's going to come across. Right? Questions, comments? What do you guys think? Do you guys believe it? So nods. Who's disagreeing? Yep. Go. Comment?
Do you think that something based on the Erlang VM would usurp something like Java instead of one of the other languages, which is also based on the VM?
Okay, the question was, why do I think that something based on the Erlang VM can usurp something on the Java VM? The answer is, that's a deep question, and I'm going to give you a couple of responses, 2, maybe 3 responses. The first thing is that I think that we may be over the concept that there is one true language, right? And the reason is very much the same. It used to be that to accumulate enough community for a language to succeed, you basically had to get all the sharp developers that would act in the community, right? So the second thing is that the Erlang virtual machine was designed to do precisely the things that we need it to do, right? So I looked at a lot of languages. 7 Languages was a book that was written in fear. And in that, I looked at Clojure. I like it a lot. I looked at Haskell. I like it a lot. I think that Haskell is probably the Lisp of our generation. Great language, but I don't think that enough of us are ready to consume it. I looked at Scala. Didn't like it because I think that there's too much in it. I think much like a great guitar player, the great guitar players can play fast, but they know what not to play, right? It's the notes that are missing that really add the air, that really give the shape to the language. And I didn't like any of those, and I kept looking. And so Elixir is interesting to me because it has elements of all those things, right? It has the Erlang concurrency model and the programming simplicity. It has the macros that are done in a safe way with rich syntax. Macros with rich syntax change everything. Even if you don't use them all the time, even if you don't have to reach for them, they increase the pace of language development, and that is absolutely critical for the success of Erlang, or for the success of Elixir. Does that make sense? So those are the reasons that I think that, that this language is important to me, and that's why I'm buying into it. And I don't think everybody has to buy into it. I think that, that we either will get to critical mass or maybe got there this weekend. I mean, look around.
So,
yeah, more questions.
So the question to me is, you pointed out, and I've seen this too, a lot of the old languages, they're getting functional features back into them. How do we get past that? I can just stay with C#, I can just stay with Java, because they're getting the functional features anyway, and I'll be able to do functional programming. How do we get past that inertia they've got?
Yes, so the question is, if I can build object-oriented applications with functional features, why would I ever move on to something else? And the answer is basically in the talk. It's how strong is the motivational fear, and how weak are the paralyzing fears. I think that those are both coming into play. The language that I'm worried about is not Java or C#, it is JavaScript. I'm really worried about that one.
So that actually feeds into a question I had about that. When you had that list up there,
Yep.
you have a whole bunch of languages plus JavaScript.
Yep.
JavaScript has a huge of institutional support, which is part of the elephant in Java.
Yep.
So how does that not just become the blessed next
Yes.
step?
And so if you look at language adoption, syntax has had a very large role, at least for the past, 30 years. And you can do some pretty cool, pretty functional looking things in JavaScript. But there is more and more noise that JavaScript is fatally flawed in terms of the type model, in terms of expressiveness, in terms of concurrency. If you ever want to shoot down, hour and a half, 2 hours, and Robert, you know this is true, you just walk up to Erlang and you say, JavaScript, run to completion, and then duck, right? So he thinks that that the JavaScript concurrency model is nuts, and he's not alone. Actually, there's a question over here first.
Here. My question is, we're all like forward-thinking people, but mostly the guy who pays our check, who signs our check, isn't.
Yep.
And I work for an enterprise that if Google does not support it, they won't buy into it. So I'm having right now a huge technical fight between Go and Elixir.
Yep.
How do we keep those people from pulling us back down when they're the ones that pay the checks?
Yeah, and sometimes you can't, right? But what you can do is you can look at, I think, you basically talk to a business person in business language. You say, this is what these new features are worth to you. This is what the lack of these features cost, right? If I have to manage these things myself, like with Francesco gave a great talk this morning, and he talked about Go, and that the big hole, the big elephant in the room, so to speak, is the lack of the monitoring and linking, and basically the error handling. Let it crash, plus the monitoring change, plus the monitoring code changes everything. So what I would do, if I were you, what I did do when I was moving from Java to Ruby is I made a business case. I didn't make a technical case, right? And follow the dollar signs. And I think that that's a valuable way to proceed. So Dave.
So I think you're right. But one of the questions I got, and this is one of those things where you ask a question and it sounds as though you're actually trying to make a point and actually genuinely asking a question.
Yeah.
Do we want it to become popular? And let me tell you what I'm concerned about. You see, there's a certain, okay, so I've been with the Ruby community now since it was, 20 people in a bar in Florida. And I've seen some really big changes. And although it is still vibrant and still really smart, there's also an element of there goes the neighborhood. To what extent is popularity a two-edged sword, and to what extent do we want to encourage it right now, or do we want to wait until we're in a better position to be able to, educate the hordes or whatever it might be.
Right, right.
And that sounds elitist, and I don't mean to. I'm raising the question.
Yeah. So the question is basically, do we want the popularity now? Can we afford the popularity now? And what's that going to do to this community? So there's always a tension with language adoption between getting enough and getting too much. And so right now, I know that the Clojure community, which is much larger, there are serious concerns with Rich and Stu Holloway. Basically, they're co-heads of Cogitech, is that right? Say it one more time. Cognitect, right. Which is the worst brand in the history of brands, by the way. Apparently not enough. But the Clojure folks do a lot right in terms of developing community. I don't think that I think that they are they think that they need more community to achieve the critical mass that they're after, and we're substantially behind them in terms of when we started, and I don't think we're at that point yet. So when it's time to put the brakes on, I'll help you put the brakes on. But I think that we have the opposite problem right now. Does that make sense? Yep. Okay.
So if we don't like JavaScript taking over, I know Clojure has done ClojureScript, which either uses Mscripton or a direct compiler to JS.
Yep.
Would Elixir script make sense so that we can do functional programming in the browser?
Okay, so the question is, would Elixir script and the browser make sense? I'm going to kind of turn that on its head. I think that in the crossing, so after Geoffrey Moore wrote Crossing the Chasm, he wrote Inside the Tornado. And this was all about technology adoption. I think one of the most important things that you can do when you're doing language adoption is to target a niche. And you can bring on everyone that wants to come, but you have to blow out your niche, right? So there are a couple of communities that I think are very ripe right now in the area of Elixir adopter. And they're Ruby developers and Erlang developers. And I'm not saying that the Elixir community will get them all, but I think that the Elixir community should be attractive for new people who are looking for tooling in the Erlang space, and people who are from the Ruby space who are really looking for something right now. I would, if I were a core team member, I would highly encourage them to really blow those niches out first. Establish those niches, and then I think that you have enough of enough momentum to kind of push on to the next thing.
We've got time for one more question with a short answer.
Yes.
Oh, we'll see what happens. So, and we had kind of an interesting discussion in IRC about this morning, and let's just assume as a limit that we want to become popular, right? Or they want to be at least very welcoming to new members. You've kind of hit face first in the past several years, like these 14 languages, and you've got some experience in being a newcomer in these different fields. I'm kind of curious, what have you seen in Elixir that is maybe a little rough edge, or maybe we could learn from other languages in terms of welcoming new members into the community?
Okay, the question is, what have I seen in the Elixir community that looks like a rough edge? I'm going to flip that on its head. I think that the Elixir community gets what the initial approach to tooling needs to be. Clojure doesn't have a great story for package management. Erlang doesn't yet have a great story for package management. With Hex, maybe they do, right? The combination of Pry with the shell is excellent. The early tooling that this language has is great, and it's hard to focus on tooling when the language features aren't done yet. So I would do nothing but tip my hat to what these guys have done. I don't know what the priorities are to develop next, but I trust you guys, and they've done a great job.
All right, let's give Bruce a big hand. Martin?